Hello again. In this lesson, we'll focus on experimental research. First of all, let's summarize what experimental research is all about. What we're looking for here is evidence for a cause and effect relationship between two variables. So how are we going to do this? Obviously by means of an experiment. The advantages of experimental research is that you can get strong evidence because you control extraneous variables that are not related to the main independent variable that you're testing. Secondly, there are disadvantages because obviously an experiment is a controlled environment in which we don't have the same conditions as in real life, so people consider that this environment is artificial, and obviously there are ethical concerns because in an experiment you administer a treatment which may have undesired effects on the participants. Another disadvantage is that it's longitudinal, so this means that you cannot do an experiment like really quickly. You need at least a reasonable amount of time. It could be 1 semester, it could be 1 year of treatment, so that you can be sure that the effects of the independent variable on the dependent variable are really measurable. And finally, obviously, this type of research is more common in medicine or in behavioral sciences. So lots of the medicines that we use have been tested by means of experiments. And yes, there is one last thing, obviously, that experimental research requires knowledge of statistics and the use of software, particularly SPSS. These are the most important components of experimental research. First of all, we start from a hypothesis. We believe that an independent variable has an effect on a dependent variable, and that's what one says by means of an experiment. But to begin with, we need to make sure that the changes are really caused by the treatment, so we need to administer a pre-test at the beginning before the experiment and then a post-test after the experiment, so we can measure the effect of the independent variable on the dependent variable. This is what we call a treatment. So obviously the experiment itself consists in the administration of a treatment. We're going to do something that is going to prove that this independent variable that we're testing really has an effect on the dependent variable. Now the experiment has a longitudinal design because the treatment should be long enough for changes to be measurable. And obviously we need two groups. First of all, an experimental group that is undergo the treatment, right? But there has to be a control group so that we can also administer them a pre-test and a post-test and see if the changes only occurred in the experimental group and not in the control group. In other words, we need to do this triangulation of results. Now, another thing that we need to do in experimental research is that we need to control the extraneous variables. We need to make sure that the effects that we're seeing in the dependent variable are only caused by the independent variable that we're testing. So we need to control all of the other variables that may be related to any kind of changes so that we can make sure that the changes are really caused by the one and only independent variable that we're testing. Now, last but certainly not least, we need to make sure that our experiment is ethical, that it's not going to affect the participants in a negative way, and usually this requires a written consent from the participants. The participants must agree to participate in the experiment in writing. This is something very, very important in an experiment. Now here's a checklist so that you can be sure that your experimental design is going to be appropriate. First of all, we begin by the participants. We need to provide a correct description of the participants, right? Talking about how they were selected and how the criteria were decided in advance. Remember that if it's an experiment, we need to select participants that are representative of the group of people or the whole population that we're trying to study. But obviously the selection of these participants must be random. So this means that even though we have a clear idea of the kind of participants that we want to get, the participation of these people must be random. So there's going to be a random selection we need to see when this selection is going to be done and how it is going to be done. Another important factor is the participants. We need to make sure that we have enough participants to develop our experiment. And remember that because experimental research is longitudinal, we need to make sure that we will have enough participants that will go through the whole experiment. So this means that we may lose some participants throughout the process, and we need to make sure that we will have enough participants so that when we administer our post-test, we can have a good number of participants on which we can draw generalizations. Now, obviously, we need to decide what type of experimental design we're going to use. We're going to be talking about this a little bit later, but it can be a true experiment, it can be pro-experimental design, or it could also be quasi-experimental design. Another thing relates the independent variable. So we may choose one independent variable. In some cases we may choose more than one, but the important thing is to see how we're going to operationalize this independent variable. In other words, so that we can measure it correctly, we need to make sure that this variable is operationalized, and we're going to see what this is all about in a little while. Now, same thing about dependent variables. Which is the dependent variable that we are interested in? And usually here we'll have just one dependent variable, right? Because we it will be very complicated to test different dependent variables at a time, and we also need to see how we're going to measure this dependent variable. Another thing that we need to do is to establish the sequential steps that we need to follow in the treatment. So we need to have from the very outset a clear idea of how the treatment is going to be administered and in what order. Next thing is that we need to see about the potential risk to internal and external validity, and we will talk about this a little bit later. But obviously, any experiment is going to have the risk of internal and external validity to be lower than expected. Obviously, another thing that we need to do is to make sure that we pilot the materials and the procedures that we're going to use. This piloting is very important before the experiment. And obviously, concerning the instruments that we're going to use, we need to have estimates of their validity and reliability, and that's why the pilot testing is very important. Now, we also need to see what kind of statistics will be used for our experiment, and a little bit later I will tell you what kind of inferential statistics and obviously descriptive statistics you will use. And then obviously we need to see how the results will be interpreted. Finally, we need to think about any possible negative effects that our participants may undergo, and obviously we need to make sure that participants' mental and physical safety will be guaranteed. Remember that their integrity is very important for us. We will now look at the most important points in the checklist in more detail, and we'll begin by the experimental design. As we mentioned previously, there could be true experiments, there could be pre-experimental design, or there could be quasi-experimental design. In a true experiment, we have all of the elements that we listed previously: 2 tests, pre and post-test, 2 groups, experimental group and control group, and then the treatment. But in a pre-experimental design, we only have 1 group. This means that there's only 1 experimental group, but there is no control group. We'll still have a pre and a post-test. In quasi-experimental design, we're going to have 2 groups, the experimental and the control group, but the thing that is going to be different, that is going to be a partial or total lack of random assignment to groups. So this means that we'll probably select some specific individuals to be part of the experimental group or the control group. This is something obviously that in a real experiment should be completely randomized. A final kind of experimental design that is worth mentioning is a single or 1 group experiment. This one is not very common, and obviously it is the less rigorous of all kinds of experimental design. In this one, as the name suggests, you measure the effect of your treatment on a single group under two different conditions. That means that first of all, you administer pre-test, you do some ordinary methodology in the sense that you don't apply a treatment, you administer a post-test. Then you give some time for transitioning, and in a third moment, you administer pre-test. Now you do your methodology or your treatments, the kind of thing that you're trying to experiment, and then you administer a post-test. So then what you're going to do at the end is obviously to compare the scores obtained in the same group under both conditions. So this kind of experimental design is not very common, but it's very used, and it helps you in cases where it's not possible to have such a controlled environment, or in cases where for some reason you lack one of the important elements of true experimental design, and where you want to administer a treatment anyway. So this is called single or one group experiments. Now, concerning the variables, it is very important that we measure the variables correctly. So there are three elements of variables. First of all, the characteristics. This is the thing that we want to measure, so we need to define the variables. Second thing is the quantification, and in this case we need to see what units or scales we're going to use. And finally, there are rules and procedures, which states the kind of instruments that we can to use, the steps that we're going to follow, and how the results will be interpreted. So as we can see, everything begins with the operationalization of the construct. This means that we need to define a variable. The construct is the abstract concept, the characteristic, the ability, or the competence that we want to measure. That is our variable. It could be our independent variable or our dependent variable. And this variable is usually complex. It's made up of different kinds of components. We must identify those concepts if we are to measure them. And once we have identified these components, we need to translate them into concrete actions or behaviors that we can observe and obviously measure. And that's what we call the operationalization of the construct. This is a graphic representation of how a construct is operationalized. So we have an ability or trait that is going to be defined, and this could be caused by other underlying abilities or traits that are even more abstract. But this ability or trait is going to be defined by different kinds of sub-abilities or sub-traits, right? That are going to be identified and then going to be broken down into different kinds of observable behaviors that we can measure. Now, this is an example of how communicative competence was operationalized in the Common framework. First of all, we know that communicative competence or proficiency is a very complex ability that requires knowledge, right, abilities, the type of personality that the person has, the view that they have of the world, the strategies that they use to learn and to express themselves. These ones are abstract and we cannot see them, but they can be reflected in the general concept of communicative competence or proficiency. Now, proficiency includes different components. First of all, for example, we have linguistic competence, and then obviously pragmatic competence, and finally strategic competence. So we know that if we want to be communicative competent, we need to have linguistic competence, pragmatic competence, and strategic competence. But these competences are also divided because they are still very complex into other minor components. For example, linguistic competence can be further divided into phonological competence, lexical competence, and grammatical competence. In the same way, pragmatic competence can be further divided into functional competence, and then discourse competence, sociolinguistic competence, and intercultural competence. And finally, strategic competence can be further divided into communication competence and learning competence. This means that phonology is going to be focused on the accuracy in terms of segmental aspects of pronunciation, and fluency, in other words, the suprasegmental aspects of pronunciation. Lexical competence deals with the range and accuracy of vocabulary use. Grammatical competence, obviously morphology and syntax. Functional competence, sociopragmatic and pragmalinguistic competence. Discourse competence, being able to write, to produce different kinds of genres, and then cohesion and incoherence. Sociolinguistic, in general terms, we can see the different social regional dialects, right? The registers and the fields. In terms of intercultural competence, we'll look at sensitivity and openness. And obviously for communication, we're going to see different strategies like planning, compensating, monitoring, and repair. And for learning strategies, how we plan, how we execute, and how we evaluate these learning strategies. So this is the construct of communicative competence in the way that is operationalized in the Common European Framework. But obviously, all of these elements that we see in the end need to be further divided so we can measure them. How are we going to measure, for example, grammatical competence? We know that we have morphology and we have syntax, but how do we measure them? Now, there is some important information that we need to include in our piloting and post-test reports. First of all, the statistical information, and in this case we'll provide descriptive statistics such as the mean, the median, the standard deviation, the standard error, so that people understand how our test worked and the results that we obtained with it. The second element is an item analysis, and in this case we will indicate the facility and discrimination values for each of the items in the test. Finally, we'll run correlations between the different components, because in this case we want to show evidence of the internal consistency of the test. Secondly, we should include information about the reliability of each of the objective sections that the test contains. And also, we want to provide some information concerning the reliability of marking, in this case, for each of the subjective sections, such as writing or speaking. There is some other important information that we need to provide in our post-test results. One of them is the results from observations that we had during the test administration. The second thing, of course, is the result from feedbacks from test takers or testers. The fourth one is an analysis of the test taker scripts. That means that we may want to have a look at what the test takers wrote, for example. And then an analysis of the candidate characteristics, and in this case we want to detect some bias. That means that we're going to run correlations between the different characteristics of our test taker population, and we're going to contrast them against the results that they obtain in the different sections of the test. Finally, we will run a comparison using statistic from previous versions of the test. So in this case we want to know how different versions of the test provide consistent, reliable results. A final important part of the analysis of experimental research are inferential statistics, which are obviously calculated in SPSS. First of all, we need to calculate a t-test, or a t. We can also calculate a p-test, called also p. We can run an analysis of variance, which is called an f. And we can perform a linear regression. Now the t-test is nothing but the analysis of the difference in the mean score between the two groups. So we need to know if this difference is significant, and we can validate the results of a treat. This can be done by independent or paired samples. The p-test measures how significant the differences are, and obviously this is measured at the 95 level, which is p when p is less than 0.5. An analysis of variance, of course, determines the significant differences across more than two groups. So it is very important to calculate the ANOVA so that we can see where those differences lie in terms of how the treatment was effective at creating a change in the dependent variable. And finally, the linear regression is a test that tries to predict how one variable, one of the independent variables, predicts the value of another dependent variable. That is important in studies where we have more than one independent variable, because it helps us to see which of them is more significant in the changes that we have observed in the dependent variable. Now let's summarize the steps in experimental research. Obviously, we're going to begin by selecting the variables. Remember that experimental research is about testing a hypothesis of the effect of one independent variable on a dependent variable. So that's the first step. Secondly, we need to select the kind of experimental and control groups that we're going to use. Remember that these selections need to be randomized. Now third, we need to operational our variables, right? We need to make measurement decisions about the kind of instruments that are going to be used for the experiment, and this involves selecting, piloting, and validating our tests. The next step will be to plan the treatment and the sequential steps that we're going to follow. And then obviously also to plan the design of our statistical analysis. We're going to see what kind of descriptive statistics we're going to use and what kind of inferential statistics we're going to use. The next step will be obviously piloting of materials and procedures that we're going to use to make sure that they are going to work the way we intend them to. And then we're going to carry out the experiment. Remember that this treatment is longitudinal, so it's going to take some time to get the results, which are going to be then analyzed in terms of statistics, both descriptive and inferential. Finally, we may require some additional statistical analysis if this is absolutely necessary. Sometimes we want to include some other analyses that are going to give us more interesting results. And finally, we're going to write up our research results. This will be the final step. Well, this is just a summary of what experimental research is all about. And each of the points treated in every slide require actually like a whole lesson about how to do different things. For example, there should be a whole lesson on how to calculate descriptive statistics, another lesson on the analysis of inferential statistics, a lesson on designing and piloting exams, and therefore I suggest that you watch some of my other videos in which I explain each of these topics in a separate way. I hope the lesson was useful. Thanks a lot for your attention.